we're going to finish our discussion of functions by talking about linear functions and some absolute value equations. So let's start by looking at a linear function. F of x equals negative 2x plus 3. The first thing that we might be asked to do is to graph that function. If we remember that f of x is the same thing as y, we can see that we have the equation y equals negative 2x plus 3. This equation is in slope-intercept form, and the slope is the number in front of the x, so negative 2 over 1, and the b is the y-intercept. So I start by graphing that y-intercept at 3, and then, because slope is rise over run, we can go down 2 over 1 to get other points on that graph. Finally, if I connect the dots, I have the graph of that linear function. Now what if we're asked to write the equation of a linear function? Well, we're going to have to remember a couple of important formulas. I have them typed out in my notes. The first one is the slope formula. It basically says if you want to compute the slope, you take the change in y, difference in the y's, over the change in x. The second formula I have listed is the point slope form of a line. So the m is the slope, and the x1, y1 is any point on that line. So let's see how these formulas work with an example. Example 2, write the equation of a linear function that passes through the points 2, 4, and negative 1, 6. The first thing I'm going to do is find the slope, and I'm going to let that first point, 2, 4, be the x1, y1, and then the point negative 1, 6 is my x2, y2. I'm going to plug those values into that first formula, the slope formula. 6 minus 4 is 2, negative 1 minus 2 is negative 3, and so my slope is negative 2/3. To finish this problem, I'm going to take my slope, the negative 2/3, and then the x1, y1, and I'm going to plug those into the point slope formula. So that gives me y minus 4 equals negative 2/3 times x minus 2. We can solve this for y by distributing, getting rid of parentheses. Negative 2/3 times negative 2 over 1 would be a positive 4 over 3. And then I'm going to add 4. 4 over 1 plus 4 over 3, I would get a common denominator, so 12 over 3 plus 4 over 3 is 16 over 3. So my final answer is y equals negative 2/3 x plus 16/3. Now let's switch topics for the second half of this video. The second thing we're going to talk about today is solving equations that have absolute values in them. Now before we solve an equation, let's briefly recall what an absolute value actually means. Absolute value refers to distance from the origin. So if absolute value of x equals 3, we are talking about all points that are 3 units away from 0. And there's 2 of them. X could be negative 3, positive 3. Both of those numbers have the exact same absolute value. So if we have an equation, absolute value equals a positive number, we're going to take that equation and write it as 2 separate equations. The 2x minus 3 could equal a positive 4, or that thing inside the absolute value, the 2x minus 3, could equal negative 4. And I can solve these equations by just getting the x by itself, so adding 3, and dividing by 2. And I do the exact same thing for my second equation. I add 3, divide by 2. So I have 2 solutions here. X could equal 7/2, or x could equal negative 1/2. We're going to do the exact same thing with example B. We have absolute value equals a positive number. So I write that as 2 equations. The 1/2 x plus 3 could equal 7, or it could equal a negative 7. To solve this equation, I subtract the 3 first, and then to get rid of that 1/2, we have to multiply both sides by 2, and that gives us x equal 8. We're going to do the exact same thing with the second equation. Subtract the 3 first, and then multiplied by 2. And once again, I've got two solutions. X could equal 8, or x could equal negative 20. Now, before you can break an absolute value equation into two equations, you actually have to make sure the absolute value is by itself, or isolated on one side of the equation. What I mean by that, if we take a look at example C, we've got absolute value of 3 minus 2x minus 7 equals 0. Before I can write this as an equation with a positive and a negative, that absolute value has to be by itself. In this case, that would mean add the 7. Once the absolute value is by itself, you can break it down into those two equations. 3 minus 2x could equal 7, or 3 minus 2x could equal negative 7. To solve, we subtract the 3 from both sides, and divide by negative 2. And the exact same thing with the other equation, subtract the 3 from both sides, and divide by negative 2. And so once again, I've got two answers. X could equal negative 2, or x could equal 5. All right, let's look at one more example. Absolute value of x plus 5 equals negative 3. Before we do the exact same thing, let's actually think about this equation for a moment. This problem is a little different from the previous ones because our absolute value equals a negative number. And that's actually not possible. Absolute value is a distance, so it's always positive. So anytime you have absolute value equal a negative number, there's actually no work to do. You just have to recognize that that's not possible. And your answer is that this equation has no solution. So anytime you have an absolute value equal to a positive number, you should get two answers, two solutions. But if you have absolute value equal to a negative number, that's not possible, and you have no solution. Let me know if you have any questions on this.